computer got stolen today, so and my Google Drive, I have everything backed up, but there's actually a sync error. So,
do you want one of us to keep it down?
Okay, if you don't mind, that would be great.
Okay. I need a permission. No. You need a permission to get
Oh, you shouldn't need it. It's open. Okay, you just request permission then. So anyway, you should just pretend that I'm giving a job talk, but like I somehow got all my slides destroyed, and I visited and something happened, and now I had to like remake my slides. So you have some sympathy, but it's still a real job talk. So anything that comes up, please feel free to make a note of it. Okay. Oh, sorry. Okay. Yeah. So so I apologize to you that it's actually going to be extremely unpolished, but that's just for you guys personally. But you should still treat it and be very critical, or anything you say can help me when I give another talk on Friday. All right. So the context is that this is for Carnegie Mellon HCII, and one thing that's actually important is that it's a social behavioral position. It's not learning sciences. So really and truly, I should not look like a learning scientist because they've hired one already. So it's very important that I look like someone who's a psychologist who does behavioral experimental work, and also that the depth of, it's much better for some technical people to not follow the talk and behavioral scientists to really get that I've thought carefully through the experiments I do, than for me to be too broad. So just giving context. And as much as possible, I actually want advice on how to make this seem more like a cognitive psychologist who's doing technology work rather than someone who's a learning scientist. So it's kind of a weird problem, but I don't want to look like that. Okay, so all right, so thanks a lot for having me here today. It's a pleasure to be able to visit. And one thing I should mention before I start is I'm originally from Trinidad, and that's why I'm going to have an accent that's sort of hard to follow, so please feel free to slow me down. And I'm also telling you, because people have said in the past that they normally miss the first 5 minutes wondering where I'm from. So now that I've told you, I guess I have 100% of everyone's attention. So the research, the talk I'm going to give today is going to be about an approach that I've been taking, which is basically to think about how do we go from basic psychology research normally done in labs and almost always involving randomized experiments to actually using that research to improve the design of technology, but then also actually taking advantage of the novel opportunity that technology provides for us to bridge the real-world context that people, designers work within and instructors work within, with the laboratory settings where most psychologists do their work. So how can we actually use the novel opportunity technology provides to do research in the real world? So there are many things that are new about online software. Things like mistakes in slides you don't even have to note. There are many things that are new about online software, but one of them is the simple transition from someone doing something on pen and paper to actually doing it on a computer. In my mind, at least, is that it brings together two contexts which are normally very far apart. One of these is a researcher's lab, where people run randomized experiments, and the other is real-world settings like classroom, or like people communicating with each other over the internet. People communicating with each other in conversations. And by bringing these two into one digital setting, it kind of gives us the best of both worlds. One is that you can get the kind of random assignments, a collection of data which you normally have in a lab, if you design technology right. This can allow us psychologists to make their theories more generalizable and characterize a broader range of phenomena, while still allowing control and precision over how things are delivered. On the other hand, by having to work with technology that's also designed to face users, to face actual consumers, you have to think about how do we make practical improvements to this by proposing design changes. How do we understand the complexity of someone working with an authentic activity? And how do we ensure that the product of our research is not just a journal paper or even a scientific statement about the world, but actually an improvement to a resource which can now be made accessible to anyone just through a URL. So the way I think about things then is really that one of our best opportunities moving forward, and this is something that many people in HCI have already explored in a great deal, but I think has been less taken up more broadly by bringing the thousands of experimental psychologists to bear on the thousands of emerging products and technologies is that online software can actually be a bridge between research and practice by aligning people's goals. So in this talk then, I'm going to first talk about, sort of take a step back actually to sort of provide context on the research I've done before, which is actually thinking about what kind of laboratory research I've done and how that might actually, how actually shedding light on underlying processes and mechanisms, even research in a laboratory, may have implications for understanding design principles more generally. And so I'm not going to actually talk as much about implementing this research in technology, but actually focus on it because I think it's a good representative example of how research in a lab on basic cognitive processes can actually pertain to real-world processes. Then I'm going to talk about how translating psychology research might move forward and work I've done, trying to not just take my research and just push it into a technology context, but actually think about how do you bridge the much broader swath of work that's been done and bring that to bear. Experiments that I've conducted in real-world contexts, which actually required going to sort of using an existing software platform and then figuring out how do we incorporate research into that actually yields practical improvements for people. And then finally, talk about the newest directions I've been focusing on, which are thinking about adaptive components, modular components that actually, given any particular platform, we can identify some piece of this that can serve to align the interests of someone who uses and designs a piece of technology, behavioral scientists, researchers who may be first and foremost interested in scientific questions, and how we can actually align both of them around some kind of shared goals in a way that, and the kind of special features of this approach are not just that it links practitioners and researchers, but actually it unifies experimentation and personalization. It allows us to extend technology, so not simply build new technologies, but given a particular piece of technology, actually make changes to it. And finally, that it's also set up in a way that is bringing to bear other kinds of researchers, not just experimental psychologists, but also people who work in machine learning, so we can actually do automated experimentation and personalization. Okay, so to start off on the first part, one thing that I focused on very heavily in my PhD and continue to is basically understanding this process of explanation. And so by explanation, I mean asking a why question. For example, why is it that someone behaves in a certain way, or why do certain patterns exist in the world? And as people here who are in learning sciences know, this is relevant to education, but actually it's pretty fundamental to cognitive psychology more generally, because a lot of conceptual knowledge actually has been shown to be structured around causal relationships and the ability to have knowledge that supports explanations for why and how. The way that people induce properties from one feature or one item to another, and how they actually form categories of the world. It also plays a key role in cognitive development. And within artificial intelligence, many approaches are focused on algorithms based on explanation-based learning. And finally, explanation is actually central just to what all of us care about as scientists, which is generating theories, answering questions about why and how the world works. So this is an example of a process where, on the first blush, it may not appear that it's necessarily that relevant to technology design, but actually given its ubiquity across a range of disciplines, and the fact that asking questions is fundamental to so much what we do, you might expect that exploring this process would actually have particular benefits. For example, if you think about, it also has advantages from a technology point of view in that if you think about people working with a piece of software, for example, a user interface that is allowing them to perform some task. The nice thing about just prompting someone to explain, for example, why does that step make sense? Or what's the next thing you're going to do? Or how does this work? Is that something that can be very easily embedded. All it requires is plain text, but actually the psychological payoff is quite powerful. Again, based on all of this existing work, simply prompting someone to explain why, or prompting someone to elaborate and construct knowledge can have a very powerful effect on their reasoning, above and beyond what you might expect from just a simple sentence or question. So the question that I focused on is basically, why is it that asking why would help us learn? So as anyone who's ever had to tutor has found out, just explaining to someone why a problem is correct can actually help you gain new understanding. Or trying to explain why other people behave the way they do, this can actually give you a new insight. That's actually kind of counterintuitive because no one's given you any new knowledge. What is it about just asking the question that actually helps you acquire knowledge or reason differently? So there are two kinds of accounts you could have of this phenomenon. One is that the effect of asking questions or explaining why are very general. It's basically that they make you more engaged. You might have to say something out loud so you're more motivated to think about it. Or it might be that otherwise you passively process information until a prompt appears and it forces you to think about and engage in what you're doing. If this was the case, then you actually would see there's not really much need for deep psychological search into a process like this. When should you ask questions? And this is something I've heard some people say of design technology for education, as much as possible. Ask people why and how whenever you can. And in that sense, then, there's no real need to understand the mechanisms because you should just insert prompts whenever you want to guide people's reasoning. On the other hand, what if it's the case that asking why and explaining actually has selective effects, where it actually evokes a particular kind of processing and the kind of reasoning you engage in is very selective? In that case, then, you actually have to be a lot more nuanced about how you design these prompts and when is it best to ask someone to explain versus present them with information or just let them engage whatever strategy they see fit for using a piece of technology. So I'm going to discuss one account that I developed, which I call the subsumptive constraints account. And the key idea behind this, motivated by working philosophy of science that's analyzed the structure of explanations, is that when someone's prompted to explain why, it actually engages them in searching for underlying patterns and generalizations. So they try to understand why the fact they're explaining, like someone's behavior, is just an instance of a broader pattern. So this term subsumption, it actually comes from work by Philip Kitcher, who's a philosopher of science. And what these philosophers of science have done over decades is look at why explanations within science, for example, why the rotation of the Earth occurs a certain way, as well as look at unusually everyday explanations, such as why is someone upset or why did an object fall off the table. And what they try to do is come up through this conceptual analysis with features that would define what is it that makes something a good explanation or makes something an explanation at all. And one of these theories is that of subsumption. So they say that what makes something explanatory is that it shows how what you're explaining, like someone's angry response, might be expected as just one instance of a generalization. For example, that person had a bad day, or that person's generally unpleasant. And then you can see how Bob's angry statement to you at this time can be explained as an instance of a pattern. Bob is generally an unpleasant person and says angry things all the time. Or, as a different pattern, Bob is angry today, and when Bob has had a hard day at work, and when people have hard days at work, it tends to make them more likely to respond angrily. So now, what kind of predictions does this generate? Now, I've tested a range of these, but I'm actually going to discuss one of these in detail. One is that when you prompt someone to explain why, they're going to be driven to seek for general patterns. So their reason might be guided to discover broader patterns and abstract patterns and principles, which actually subsume the particular observations they're explaining. Another is actually concerns subsumptive scope. So explanations are going to be better to the extent that they can unify or subsume multiple cases under a single generalization. And so this can often be helpful by promoting discovery, but I'm actually going to talk in detail about the strongest test of this theory, which is actually show that even though I found in my research many cases where explaining helps people discover abstract patterns, the best way to rule out the possibility that explaining is still just boosting general attention or motivation is to show that under the right conditions, explaining can actually hurt learning. And the key idea here is that even if a process might be generally beneficial, and so we want to use it in design, understanding the exact mechanisms under which it works and operates will actually help us avoid cases where it might actually be harmful counterintuitively, and also help us identify those cases where it's most beneficial. So here's the basic logic that underlies our prediction of these what we call explanation impairment effects, which have mostly not been documented in literature. The key idea is that if someone explains and patterns are reliable, then actually, if you think the explaining is just about being engaged, then you should expect learning to be enhanced, or at least not influenced. If you think explaining there are patterns that are unreliable or misleading, well, in that case, explaining should still enhance learning, because even if there are underlying patterns that hurt learning relative to reliable, you're still going to be more motivated, you're still going to pay more attention, you can handle this information better than if you weren't explaining at all. On the other hand, the substantive constraints account predicts whenever someone asks themselves why, such as why a person acted in a particular way, it forces them to seek an underlying pattern. Now, when those patterns are reliable, that's going to help them reason. They're going to be able to find abstraction that accounts for behavior that they can use in a wide range of situations. When those patterns are misleading, explaining is actually going to cause them to reason incorrectly and make incorrect predictions, because regardless of what data they observe, they're going to be driven to find these patterns and use them in a maladaptive way. The key idea here is that constraints on explanation should actually interact with the structure of what you're explaining. So here's one experiment that I conducted that actually dealt with people learning categories. And this is a laboratory experiment. So the key idea is that people are told there are two kinds of objects they should be learning about. They were called DACs, DAXs, and KESs. So here's an example of a DAX. It's purple, it has 2 doors, manual transmission, heavily insulated cloth seats. Here's a KES, cyan, 4 doors, or auto transmission vinyl seats, made in Africa. Now, it may not be apparent, but it's more obvious when you see it all laid out, but I'm going to give away the structure. One is that there were always unique features of each of these items. So you could basically just learn that there's a purple DAX, there's a purple item, it's a DAX. Silver, there's a DAX, cyan is a KES. These other features, 2 doors, manual transmission, weren't predictive of anything. On the other hand, there are these actually subtle underlying regularities. Can anyone see that? What those might be? So if DAXs are heavily insulated, made in Norway, and have treads, versus DAXs are made in Africa, used on safaris, and lightly insulated, DAXs seem to conform to this abstract pattern of some kind of cold weather vehicle, and KESs to be some kind of warm weather vehicle.
So the question, DAX is the name of it?
It's the category.
Oh, a made-up category, right?
Ah, that wasn't clear.
And the made-up.
A made-up category, exactly.
Made-up category of what?
Of object.
Just like in tiny.cc.
So so that I can correct the misconception, what was confusing about this? What do you guys think when you saw it?
DAX is the name of the person.
Ah, okay, got it. Okay, good. Okay, I'll be clear right now. And so now the key idea was there's an extensive literature on people learning about categories where they can learn by individual features or they can learn by general patterns. And so the key idea here now is to what extent will explaining push you towards one or the other. So here's the full structure. What we did is we had 2 conditions. One, so we always have, in all the experiments that I've done on this topic, there's a condition where people are prompted to explain, and there's a control condition where they may either use any strategy they want, or they're prompted to say their thoughts out loud, or they're prompted to describe. There's a second factor here, which is whether the pattern is reliable. And so in this case, this theme of being a cold weather or warm weather vehicle worked 100% of the time, or the pattern is actually misleading. And so in this case now, the misleading pattern only worked for 8 out of 10 items. So for example, there would be 1 DAX that was actually used on safaris, or 1 KES would be heavily insulated. So the pattern would help you make predictions correctly some of the time, but there would always be persistent mistakes you would make. In the experiment, Participants to explain that the task was to learn about these categories, and in particular to learn to correctly predict each of these. In the training stage, there was either the explain condition where people were prompted to explain, or the classify condition where they would be classifying objects but also have to say out loud what they were thinking. So for example, they'd see an item that might be blue, have 2 doors, manual transmission, and so on. In both conditions, they'd have to classify. So they'd say, okay, I think it's a KEDS. Then they'd actually be given feedback. No, that's wrong, it's a DAX. And then here's where the condition diverged. In a classify condition, they would simply be told, this is a DAX, and see the item again and just be told to say out loud whatever they were thinking. In the explain condition, they'd have to go above and beyond that. They'd be told, explain why this might be a DAX. And so it's actually a very subtle manipulation, one that's a lot easier to do in the lab, where they're verbalizing in both cases. So we're trying to rule out the possibility that it's just having to use language that might be helping people discover or learn about these items. And they also are forced to pay attention, because they can't just be looking away, they've actually got to engage in active articulation. But in one condition told, explain why this might be a DAX. With the other, they're just told, say out loud what you're thinking about this DAX. So then after training, during training, we got measures of how accurate they were by seeing how these classifications improved over time. But after training, we wanted to get additional insight into what they were learning about these items. So we actually gave them features to classify. And I'll talk about this more later. And at the end, we just explicitly asked them what they thought the differences were. So here's the key finding. On the vertical axis is the number of blocks it took people to learn. On the horizontal axis is whether the pattern was reliable, so it worked for 10 out of 10, or misleading, that only worked for 8 out of 10. And we have the explain condition versus the classify condition. What you can see here is that there's an interaction. So explaining was slightly beneficial for learning when the patterns were reliable. When the case where the pattern was misleading and there were exceptions to it, explaining actually hurt learning. It was better to not explain at all, because that actually slowed how many repetitions and how many times people had to see an item before they were able to learn to classify it correctly. So in terms of understanding, our hypothesis about why this is the case is that explaining forces people towards patterns. And in the reliable condition, that helps. In the misleading condition, it hurts. But to more directly test that idea, what we also did was look at the present people with just individual features and ask them to classify whether they thought the feature belonged to DAX or KEDS. So for example, they just see the color cyan and say, do you think that something cyan is a DAX or KEDS? Or they'd be given a feature like heavily insulated and told, do you think that the heavily insulated item is a DAX or a KEDS? So what you can see here is that in the reliable pattern condition, the theme have warm weather, cold weather vehicles. People in the explain condition were more likely to correctly classify those features. On the other hand, when it came to color, you saw the exact opposite effect. So these unique features, people in the classified condition were actually much more accurate at using those. So what you're seeing here is the same dissociation where people explain seeking underlying patterns. People who are thinking aloud or classifying are focusing on individual features. In the misleading pattern condition, what's interesting is you see the exact same thing. People explaining are still better at using the pattern, whereas people classifying are still better at using individual features. Now, of course, what you see is that people in the explain condition are not as good at using the pattern. Overall, they're better in the reliable pattern condition. So they are somewhat sensitive to the fact that these features aren't perfectly predictive, but still explaining, because it's constantly driving them to seek patterns and use them, doesn't completely overcome this bias. And so kind of returning to the original question, these experiments provide really compelling evidence that explaining isn't just increasing people's attention and motivating them, it's actually exerting a selective cognitive constraint that drives them to seek patterns. In most cases, they're reliable principles in how to use a piece of technology, or they're reliable patterns in other people's behavior. But in some cases, the explaining can actually hurt learning when these patterns are not reliable, or when people actually may lack the knowledge to discover them. And this provides pretty strong, this sort of explanation impairment effect that we discovered here provides pretty strong evidence against the idea that it's explaining is primarily helping learning through engagement. In this sense, you might think of the kind of approach we're taking here as analogous to the study of visual illusions in perception. Understanding the conditions under which the visual system works fine actually is not that informative about shedding light into the processes by which it works. But visual illusions are an example where the normal functioning actually does something wrong. It shows an effect that doesn't actually exist. And in the same way, even though explaining is mostly helpful for learning, identifying the conditions where it actually hurts learning can be like visual illusions and expose the underlying mechanisms. So there are a couple issues that you might have with the concerns we had with the previous experiment. One is that this condition of thinking aloud, it could be that suggested to people that they didn't have to focus on features of the items, or to be that actually distracted them from the task. Maybe it's actually not that explaining as a process helps people find patterns, but just being told to explain makes them think that some pattern might be there. Another is that the task is relatively constrained to learning about categories. To what extent would this generalize more broadly? And on that theme of generalization, we also want to know what would happen if we included multiple different patterns and a very different kind of context. So we looked at a new task that was formally analogous, but actually very different in terms of the actual items. So this actually involved learning about people's behavior. So you can imagine a hypothetical person, Anna. So we present participants with a description like, Anna's 37, she's dominating, she lives on the East Coast. Do you think she rarely or frequently donates to charities? People would formulate an idea, and then they'd actually be told, well, actually, Anna rarely donates to charities. So they're implicitly given information about whether they were right. At this point, they'd either be in a study condition where they would be allowed to study this observation any way they want. They weren't told they had to think aloud or anything else. All they were told at the very beginning of the experiment was, when the experiment's done, you're going to have to explain for individual people why they might engage in the behavior they do. So in both conditions, now people are told they'd have to explain the future. But people in the study condition could use whatever strategy they wanted, whereas people in the explain condition were actually prompted, why do you think Anna might really donate to charities? So this was a very nice sort of control, and it complemented our previous study. In our previous study, we compared explain to think aloud, where they both had to perform a task, whereas now we're actually not forcing them to do anything. So we can rule out the idea that thinking aloud distracts people. And we've also actually matched these very perfectly in that the expectation that people are going to have to explain is there in both conditions. So if it was just a matter of the experimenter cluing you in or letting you know there's some pattern, then there should actually be no difference at all between these. If it's actually the case that engaging in the process of asking why is what drives you towards patterns, then we actually should expect a difference. So, experienced person rarely donates to charities. So now, again, as in the previous study, but with totally different materials in a very different context, we present a reliable pattern. So for example, here, people who are outgoing, dominating, or friendly or boastful rarely donate to charities, and people who are introverted, cautious, studious, frequently donate to charities. Just as a side point, we actually did, in the study which we did in the previous, we counterbalanced this. So we also just, for half people, they were told that extroverted people frequently donated, introverted people rarely donated. So we controlled for that, and there wasn't any effect of it. What we then did for the sleep patterns, we swapped two of these. So there was one person who was quiet, but rarely donated, one who was energetic, outgoing, frequently donated. We also actually included a second pattern, and that was that people who were older tended to really donate to charities. People who are younger tend to frequently donate. Again, for the reliable pattern, that was always true. For the misleading pattern, two of these were switched, and we also counterbalanced. So in the actual experiment, we again predicted to find one of these explanation impairment effects. So I think. So what we actually did find was exactly that. When the patterns were reliable And now we had a very different measure of learning, of judgment. We didn't actually look at how long it took people to learn. Everyone had 5 exposures, but then we looked at their predictions during the experiment and looked at the predictions afterwards. After everyone had the exact same amount of time to observe people in the reliable pattern condition who explained were more accurate at predicting how someone would behave, while people in the misleading pattern condition were less accurate than the control condition. And again, we found this was actually driven by people in the explained condition focusing on those general patterns, and people in the control condition using individual distinguishing features of persons. So what we see now is, again, across both of these experiments, the very different materials and very different learning tasks, we actually find that explaining is helping learning by driving people towards patterns. But even when that isn't aligned with the goal of learning, and even when people are getting feedback, it still actually misleads them. So this provides evidence that, in some sense then, understanding the mechanism by which explaining works is actually essentially critical to design, because there might be cases in which explaining would actually harm learning against the goal that you're trying to achieve, or misdirect people's reasoning. And we've looked at other literature that's been published in contexts like stereotyping, where actually there is interesting evidence there that when people have the opportunity to generate explanations or come up with narratives for people's behavior, you may be more likely to find these overgeneralizations, where people may be more likely to stereotype or use general categories versus rely on individual information about people. And what it also suggests is that, again, by analogy to visual illusions, this kind of boundary case of when explaining hurts learning provides really strong evidence that explaining drives people towards patterns. So it means that when you want to prompt someone to explain is when there's a principle to be discovered and when you think they have the knowledge to discover it. In many cases, actually, that may not be the case. So you might actually think that it's more helpful to not tell someone anything, or to actually give them information or give them an explanation, if prompting them to explain wouldn't help them find it themselves. So there was a whole range of work that I didn't talk about, but centered around this topic. One was the original work proposing these substantive constraints theories and providing evidence that explaining drove people to find patterns and to more abstract characterizations. Another was actually finding that there was interaction, not just between explaining and whether patterns were reliable or not, but between explaining and the knowledge that people had. And so what we actually found there was evidence that explaining might act as a mechanism by which people's existing knowledge is brought to bear in reasoning about a situation. But in the absence of prompting people to explain, that knowledge may not be used. You might think that these effects would be restricted to undergrads or people of a certain age, but actually children as young as 5 show this exact same pattern, where prompting them to explain instead of describe makes them find more abstract patterns and also makes them bring their prior knowledge to bear. So this, again, provides insight into several theories of cognitive development. In the most recent work, what I've looked at is, if people are driven by explaining to use these misleading patterns, how can we actually overcome that? And one thing we found is, again, some interesting interactions where, depending on how much information you give people that contradicts with their prior beliefs, that interacts with whether explaining is able to help them overcome it, and also how you distribute that information. In collaborative work with Brian Edwards and Dedrick Gentner, what we've also looked at is the relationship between explaining and processes like comparison. So comparison has also been shown to help people find underlying patterns and generalizations. And what we've done in that work is characterize the extent to which comparing and explaining interact, since both processes can drive people towards finding patterns. And one thing I think I would point out is, especially trying to build this work towards being able to help identify generalizable design principles, is I moved from artificial categories like robots over to images not showing up, over to categories that are more naturalistic, like descriptions of objects, and then finally to actual people's behavior. And most recently, in the context of actually people learning how to explain math. So, switch over to that. So in the second part of my talk now, having talked about that as motivation for examples of lab work that can identify useful mechanisms. I'm actually going to talk a bit more about now how we might, oops, sorry. How might we actually now think about stepping towards psychology research out in the real world? And in particular, as I mentioned earlier, I think that technology and online software has a unique role to play in this because it basically brings together contexts like the ones I've talked about, which allow environments with actual real-world interactions that people are engaging in. And one thing I'll say is that in pursuing this work, there are a number of changes I've made that I wouldn't have stepped towards originally when I was just pursuing this straight out of, from the perspective of having a psychology PhD. One of them is I've realized that very much this work has to be in some sense bounded or constrained psychology research. So what I presented before is psychology research I do when I have full control over everything and I know what the constraints to satisfy. But in the same way that Herb Simon has pointed out that there's unlimited rationality and then there's actual rationality when there are resource constraints. In some ways, doing psychology research in the real world has got to be bounded in the sense that I found you have to think about, of the set of interesting research problems that I might or other psychologists care about, what's the set of research problems that also warrant practical improvements for the designers of a platform? And then within that already small intersection, what's a set of practical and research projects that actually can be answered given a particular technology or given a particular platform? And in this context as well, I should mention that a lot of research that takes a similar kind of approach doesn't necessarily try to work with existing platform providers. You can build new kinds of technology and discover interesting design principles by using laboratory studies or by hosting something on your own website. I think that's actually a very important research, but it's also very well, there are a lot of people who already go in that direction. And you think of research as sort of placing bets or trying to characterize unique parts of space. What I would say is a bit different about my approach is that I actually try to think about the problem of these large-scale existing platforms and technologies. If you, given that I have to work with one, or if you sort of give me one as the input to my research process, how do I actually then take that and engage in research that allows experiments to be run that are of interest to psychologists, but also yield benefits to that platform provider? And again, I think that there are pros and cons of this, but there are less people who've been focusing on this, and I think the unique advantage there is that you could then actually make changes to actual existing systems and also show many people who in this kind of context the value of collaborating with behavioral researchers. Another thing that I'm going to talk about a bit is the distinct position of not just taking my research and pushing it straight into another environment, which is what my first impulses do, but actually thinking about the role that I might play in terms of integrating what other behavioral scientists have done and bridging that kind of expertise with the particular practical problems that are faced. Because not every problem is going to be answered exactly by research or explanation. And in the third part of, final closing part of the talk, I'm going to focus on what are my most recent directions, which is having engaged in this kind of work. What are the concepts? What are the workflows? What is the software that I should think about designing, where the users are not just end users who are reasoning using a website or making decisions, but actually are researchers, the thousands of behavioral scientists who attend conferences like Association of Psych Science or American Education Research Association, or the actual instructors just trying to teach a course, or people who work as designers on a platform. And also the developers and engineers who actually have got to build or adjust the technology that we might use. Oops. Okay, so the first line of research that I am engaged in thinking about these online environments actually pushed me to consider a broader set of research than what I'd originally done. So, for example, in looking at doing a extensive review of existing platforms and the technology they provided, for example, Coursera, Udacity, edX, Khan Academy, what I was struck by was that the particular, while explanation is a broad process and there were many situations in which it could think have a good chance of improving people's reasoning and judgment and learning. The often platform providers were concerned with a much broader set of issues. So in speaking to someone who was a practical instructional designer and seeing things from their perspective, they often had very particular approaches, metrics they want to improve, like, for example, engagement on their site. And they also had a very different set of beliefs from me and other behavioral science about what would get there. And so I found that actually being able to draw on a broader set of literature and approaches was actually invaluable in actually being able to execute this kind of research. And so one thing I did in pursuit of that was actually to collaborate with some clinical psychologists, where the key idea of this work has been to develop a notion of cognitive support. And what's meant by cognitive support is actions and manipulations and changes to instruction, or actually just any process that can actually provide additional support for what people learn from the situation and what they actually retain and apply. And so the idea here within clinical psychology context was there are thousands of therapists who are currently teaching people or providing therapy to people on how to handle depression or anxiety and the topics. And there's been a lot of research on how to teach such therapy, but there's actually been less research on there's been a lot of research on what kind of therapy is effective, but there's been much less on how do we actually ensure that people retain what they've come across and that they actually apply it in their real life. And so this work is covered in a recent Perspectives in Psychological Science paper. But what I did in collaboration with clinical psychologists is draw on the knowledge base, not just of what I've done in terms of explanation, although that was one important form of cognitive support, prompting people to reflect, but actually draw on research from a wide variety of areas in cognitive and social psychology. For example, looking at how testing patients, as therapists were speaking with patients, testing them to see if they would recall concepts, or helping patients draw analogies by comparing examples of situations. And that review is covered in that paper, but one thing that's also come out of that has actually been what we call the cognitive support rating scale. And it's actually a rubric that we developed for looking at a therapist's interaction with the patient and coding them to see to what extent do they use each of these 7 cognitive support strategies we've outlined. And in moving forward as a future direction, what I really looking to do is think about actually using that scale as applies to technology. So given a particular app, for example, in helping people learn to make better decisions or helping people change their habits, to what extent does that app take advantage of these principles of cognitive support? I think this approach is something that can also be very much generalized to other psychology research, for example, on behavior change and habit change. One particular project that I engaged in along these lines was something like a mixture of a hybrid lab and online context. So in this study, which is under review at Behavior and Cognition, Behavior Therapy and Cognition, and Cognitive Behavior Therapy, is actually about a hybrid where a sample of about 25 people who were classified as having mild depression were brought into lab context and were given exposure to some of these lessons we developed with cognitive support. And the actual primary role that I played, that I focused on there was not just designing cognitive support, but actually thinking, how would we actually measure whether these sessions were having any effect on people's behavior? Because now we're not just measuring short-term measures in the lab, we actually want to see out in the real world. And so, for example, one thing that we developed and validated in the course of this was asking people to report how often they recollected information from the session, sending text messages to people, and seeing to what extent they actually responded and acted on those, and then actually designing some situations that matched real-life applications of what they've been learning. And so that's, I think, one example of a step that's sort of trying to bridge research that's been primarily conducted in a lab context with a real-world online setting. And I think actually the key contributions experimental psychologists are able to make, at least that I've been able to, are not just knowing what literature exists and what kinds of things are effective, and not just designing experiments that can identify design principles, but actually also designing measures of people's behavior, whether they've learned something, whether they have a certain belief, and whether they actually like to take a particular action. So in the context of, let me switch back. So the research I'm going to talk about now is actual experiments that were embedded within online platforms. And one thing I should say is that these examples are all going to be educational. And this is not because I'm necessarily committed to these as a topic. In fact, the area that I would like to explore very much moving forward concerns issues like behavior change and habit change in decision making. But actually that I found that there's been a lot of recent excitement in terms of education. It was actually found instructors were very open to applying research, and that just in terms of having a core focus that would again give credibility with collaborating people in this context, this was a much easier case to make in terms of online education. But the other areas that I have sort of done work in and been prepared to do research on with collaborators are decision making and behavior change. And I think all of the lessons that I've learned and the work that I characterize here is very much designed to set the stage for that kind of work as well. So I think in the interest of time, I'm only going to talk very briefly about this. But this is an example where I took a step beyond the stepwise kind of experiments I do in the lab to pin down exact mechanisms to basically something that's much more like how a psychologist might approach a design experiment, where I had different conditions. But these weren't meant to rule out one specific hypothesis so much as designed to test some methods for improving a practical outcome. In this case, this is work with Khan Academy, provider math exercises. And from discussions with them, what they really wanted to improve was how many problems people attempted to solve, and also people's accuracy or their learning gains to solve these problems. And so drawing on the research that I'd done on how problems people explain to help learning, but also integrating insights from reviewing behavior change and habit change research. What I did here was actually, I'm just going to go through this quickly, was actually add different kinds of text above the exercise and teach people different self-questioning strategies. So for example, instead of just prompting them on a particular exercise to reflect, now I tried to go beyond, can you actually teach someone the general strategy of asking themselves questions? And this draws on a set of work in education, as well as an important set of work in habit and behavior change. And the key technological component here is that teaching people general strategies has been enormously hard. It's actually most literature is showing the ways in which people fail to do so and how extensive training is required. On the other hand, online platforms provide a unique environment. One is because by allowing us to do these experiments, we can really pin down exactly what kinds of questions are effective. So we can pare down things that normally take several months into smaller interventions. But the other is that this kind of technology is ubiquitous. In the same way that ideally we'd want someone there constantly tutoring us and reminding us to ask questions or use strategy, being able to just give these repeated prompts is actually a novel opportunity that's available in technology but not out in the real world. So the idea here is that, again, simply just inserting into an exercise in a place where you think we couldn't even get much traction, click here to learn about the what, why, how strategy. And so when people clicked, it would just pop down. Tiny minority of people actually clicked, and they'd be told, ask yourself these questions after each hint or problem. Like, what does it mean to you, or why is it helpful? To give them cues to actually reflect and remind, we'd actually embed sometimes after a step, why is it helpful to take this step? We tried 4 different kinds of prompts, which I won't get into detail about, but what we actually looked at was not accuracy on the items where the prompts showed up. In a way, that's very easy because while the prompts are there, you're going to use it and your learning should increase. We actually looked at results on the post-intervention problems, so after we'd actually stopped showing these prompts at all. And what we actually found is that there were small but reliable effects where you get about a 0.7 or 0.8 increase in accuracy on the problems that you saw after these prompts were appearing. So people did actually seem to internalize the idea that they should engage in this kind of self-questioning, and they were actually doing better on future exercises. So that in some ways followed on naturally from the explanation work. But the second kind of experiment, I think, is an example of the approach that I've actually been pushing more towards taking. And that's where I don't just rely on my particular core expertise in the experiments that I specifically run, but actually use the psychological knowledge to identify researchers who are going to be particularly germane to meeting the practical goals of a platform. So as I mentioned, one thing that Khan Academy was extremely interested in was boosting how long people spend on the site and how many problems they attempt. So what I did here was work with some researchers at Stanford who work on social psychology theories of how people are motivated by their beliefs about whether intelligence is malleable or whether it's fixed. So this is work by Carol Dweck, who I think many people might have heard about. And the key idea here is that even though whether you hold this belief or not has been shown to be a good predictor of whether you, in the face of trouble, you give up easily because you think intelligence is fixed and you can't do much, or whether you actually keep on working and push through because you think that every time you make a mistake is a chance to get better, there's been less work actually on how do you teach a growth mindset. And one key issue that's been persistent is the effect of believing intelligence is malleable. Is that just really all about encouragement? That you're telling people, they can do something so they have some confidence in themselves? And so using the same kind of experimental paradigm as before, what we did here was design motivational messages, and the practice usual condition was just people solving math exercises in Khan Academy. There are about 12 different fractions exercises. The growth mindset message condition were given messages like, remember, the more you practice, the smarter you become. And so now what we compared here, and this is work with Josh, the Solvik students at Khan Academy, as well as people at Stanford and Carol Dweck's group, was compare these two conditions. For example, another message might be mistakes help you learn, think hard to learn from them. And what were the results? Were people actually more motivated? So we looked at the number of problems that people attempted, and what we actually found here was a 0.9% increase. Even though there's reason to think most people aren't even reading these messages at all, we are seeing a benefit. How many problems do people get correct on the first attempt? So not that they're just trying to get more things correct, trying more things, but are they actually improving so that they're getting more of them correct without asking for hints? We're also seeing a benefit in that. And then finally, which was really impressive, is that if you look at how many problems people get correct on the first attempt versus how many they get correct overall, what we're actually seeing is that there's a pretty small but reliable increase in accuracy. So now you might have a couple of concerns about this. One is, isn't this kind of obvious? If you give people messages encouraging them, then of course they're going to do better. And you might be skeptical, well, with that large an N, 50,000 students each condition, anything statistically significant in an online environment. So actually, here's a second comparison we ran at the same time. Not just practice usual versus growth mindset, but there was actually a positive message condition where we told people some of these problems are hard, so just do your best. Other than that, the condition was the same. So does any positive message work at all? Another message might be, this is a tough problem, but we know you can do it. So if any kind of message is effective, then you're going to see the same kind of benefits of people solving more problems and being more accurate. In fact, positive messages are not any better than showing people nothing at all. Growth mindsets are better than positive messages. So not anything statistically significant once you have enough subjects. What's interesting is adults judge these messages as equally effective. So when we give this to a sample of 40 adults, we give them the exact same messages in each condition and told them the context they'd be used in. Adults either thought they were 20% of people thought mindset better than positive, similar proportion thought the opposite. Most people thought they were equally effective, tiny thought neither. People's beliefs here don't at all line up with the reality. Even though people think that both of these are going to be effective and better than nothing at all, positive messages are not any better. Growth mindset messages really tap this very subtle belief about intelligence being malleable are what makes a difference. So the most recent work that I've been focusing on has actually now been considering so the kind of future directions I want to pursue now are thinking, given the kind of approach that I've talked before about lab research and then research that embeds these experiments in online settings, how is it that we can enable a much broader range of behavioral scientists and practitioners to collaborate in this kind of work? And so what I've been trying to work towards is how we can distill some of the insights from looking at the challenges technologically, and also in being able to align practical concerns of instructors or people who design software with the behavioral scientists who want to ask critical scientific questions, help me to actually enable more of that work. And in drawing on this, I've looked not just at the work I've done in collaboration with Khan Academy, but also trying to embed experiments in edX, which I didn't talk about, and other collaborations that looked at embedding them in NovoEd, a sort of social collaborative-based platform for business. And then actually things like learning management systems, so Moodle, the things that instructors actually use on their campus, and that's been in a medical education setting. So the kind of key ideas that, the key barriers that have come out have been, especially in a practitioner being able to have a discussion with the researcher about what kinds of things will be varied or will be changed in an experiment. Practitioners being very unwilling to or concerned about giving up control over their particular platform and content being made, and researchers also being very uncertain about what can be experimented with, what can be randomized, and what kind of data can be available. And so this concept that I've developed with collaborators in terms of a MOOClet or some kind of modifiable component has been actually aimed at satisfying these design goals. And so the key desiderata for this are, one, well, actually, is actually supporting behavioral scientists and practitioners, but also actually allowing a very clear understanding of what the technology constraints are in a platform, and enabling actual redesign of platforms. So as I mentioned, not simply when one builds a platform or technology themselves, we can change anything we want, but actually how do you basically take an existing platform like Khan Academy or edX and then allow behavioral scientists to do research on that platform that hits practical goals and scientific goals while respecting the constraints of technology. The kind of key enabling insight into this has one bit on modularity, appropriately scoping what's going to be changed, but actually also something that I gained from actually looking at technology and a paper at Learning at Scale that compares technology of experimentation across Khan Academy, assessments, and edX. And that's actually that you can formalize a relationship between doing experimentation and personalization. So in this context, then, you can actually think of an experiment as delivering different versions of a lesson or of a web page to someone based on a variable, but that variable is set randomly. You can think of personalization or adaptation as delivering different versions of a website or page or message, where what's delivered is conditioned on a variable, but that variable is actually now set using characteristics of the user, like how much exposure they've had to a website. Once you formalize that relationship, you can actually define a design pattern for a component that actually gives many of the features that I've been aiming for here. And so the idea is that one of these modifiable components is defined as a MOOClet, if and only if. It's a user-facing component that you can make multiple versions of. And these multiple versions can be presented as a function of a set of variables associated with a user in what you might think of as a user variable store. And this user variable store can be modified dynamically. So it's a very simple kind of idea, one that you would think would exist in most platforms. It doesn't actually exist in any platform that I've seen so far for online education, because normally people don't conceptualize experimentation and personalization as the same thing, and they don't normally implement this particular design pattern. But once things are implemented this way, it actually opens up a really broad range of possibilities, and this is what I'm exploring at the moment. One is actually that it makes it a lot easier for practitioners and researchers to talk about what's going to be changed in a platform. For example, will it be this one web page or this one lesson in week 3 of a course? In that case, then it can be very clear to the researcher what versions of a lesson they want to present, which will allow them to do a randomized experiment that rules out particular hypotheses. And it's also clear to the practitioner what different versions of content are going to be tested and what the effect is for which are going to be better, what the hypothesis for which will be better or more effective for their learners. It also clarifies what information is going to be collected by a particular MOOClet and passed to this user variable store. So actually in real time, the data can be analyzed. And I've actually implemented a test case of this design pattern in both edX and also Moodle, which has actually been used successfully to actually deliver content to students. Another thing is that you can actually now external to the particular details of what this content is or what these variables are, you can actually now link a set of machine learning algorithms to actually be updating these variables. And so essentially what this means is that any MOOClet or any component implemented as MOOClet is essentially a reinforcement learning agent. So even without, all that has to be specified by the practitioner or researchers is what the outcome is to be maximized, like how long people spend on a page or how well they do on a subsequent exercise, what the different versions are, and then the reinforcement learning algorithms like Markov decision processes or POMDB's multi-AMP bandits can then actually be applied directly without actually having to know the details for implementation to optimize these. And of course, finally, even without knowing the engineering structure of a platform, you can actually know that you can experiment on these particular dimensions and you can personalize on these particular variables. What's especially important in the implementation in contexts like edX is the idea is to, the first time that I was trying to run experiments in Khan Academy and edX and Moodle, basically one thing you might get would actually be a file that had the code for the website, where you'd actually have to modify the architecture in some way. But the key idea here is to place a user-facing component in front of that actually allows you then to take any platform, inject something that's user-facing, and test out which versions work, which has actually been successful in allowing us as behavioral scientists to run quick trials, which might then lead to greater change on the platform itself. For example, the experiments that I presented earlier about the motivation message in Khan Academy, while those effects are relatively small, just having that data then actually led Khan Academy to launch a campaign which was called You Can Learn Anything, where they actually went beyond that particular experiment to say, how can we maximize this effect? And they actually posted videos on the website and sent out email campaigns explaining to students that they could get smarter by working hard and investing effort. So then even just small experiments that are implemented quickly with this kind of approach can actually have a much larger effect. And so I think that these are the directions I really want to work in, and especially not just in the context of online education, but also settings like behavior change. So I think that covers everything there, actually. So just to close, the talk so far has covered examples of work in cognitive psychology that have implications for practical design by identifying underlying mechanisms, such as explaining why helping learning by driving people to find underlying patterns, how we can translate psychology research to these kinds of environments by identifying principles from a range of literature, not just primary research I've done, and then actually experiments in real platforms, such as on motivation. And finally, the future directions I'm focusing on, which I think go beyond online education to contexts like behavior change, habit change, or any kind of actual interaction with a piece of technology, which use these design patterns that unify experimentation and personalization to make it easy for behavioral scientists and practitioners to collaborate and allow us to even not just improve technology by crowdsourcing or bringing together researchers, but actually through automatic improvement in algorithms. And these directions I'd be excited to talk about more. Okay, that's everything. Thank you.
Thank you for questions from the audience. You got a slide titled "The Product Range of Psychology Research."
Yes.
Can you tell me, in one sentence, what was the impact of the work you described then?
It was I think it was relatively limited. It was a publication to a clinical psychology audience about effective strategies from cognitive psychology that could be used in improving memory for therapy. 2 sentences also a cognitive support rating scale that's been validated for analyzing people's publication of a cognitive support rating scale that clinical psychologists can use to see the extent to which therapists are supporting patients' memory.
Are we on technical questions or?
Yeah, still technical questions. Okay, high-level feedback.
Half of your audience will not be learning science books.
Yeah. No, and I don't want to even like focus on that. I need to say how I'm not learning science. Yeah.
The people, everybody in the audience needs to be able to leave the room and be capable of answering the question, what was the talk about?
Sure.
I'm not able to answer this question.
Okay. So if I said that it was about
Maybe we can take a look at slide 2. I lost you there already.
Okay. This one or this one?
That's slide number 3. Sorry. So what was the motivation for the entire talk?
That designing online software in the right way allows us to do experimental psychology research at the same time as make practical improvements to technology.
My understanding when you were giving explaining, saying, spending time first couple of slides, my understanding about your upcoming talk would be applying your experiences in research lab to real world setting.
Yeah.
But you are now saying something different.
Yeah. Yeah, and that's a kind of just tough tension where I need to talk about the basic research because that's most of what I've done and that's what they would hire me on. And like Ken Gooding said, and other people said that very directly, is that you need to put good examples of psychology research. But it's less clear how to link.
The clarity of the message.
Okay, is the clarity? Okay.
Don't waste your time on being defensive. Ask us questions.
Okay, no,
So there is no apparent link between this motivation now explained and the overview. So the overview. So if you state the problem as building a bridge between research lab and practice.
Yes.
The slide 3 does not respond to that challenge.
Okay, sure.
I mean, one of the bullets does, but it's not. If you present.
Yeah.
Your roadmap has to be a roadmap towards solving a challenge that you set out for yourself.
Yes.
So you're saying that your goal is to improve online learning environment from psychology knowledge that you have from research lab.
Yes. Yeah, that's right. Yeah. But not just online learning. I just like to say.
You just said that.
Yeah, no, I know. It's a problem, but because I mean, most research is on online learning, but I think I'm trying to make a more general statement. Is this just any kind of online environment using psychology? It's just the examples happen to all be learning and education.
Can you give an example of not learning online platform?
Yeah.
In the same context as the learning?
Yeah. So, for example, getting people to quit smoking.
That's one example of behavioral change.
Exactly, yeah.
So at the later phase where you're told, you said the behavioral change several times without giving us any context of what behavioral change you
Sure.
mean by.
Got it, yeah.
I think you said 3 times behavioral change.
Sure, that's a very good point, yeah. Yep, no, that's a good point. That would help a lot. One thing I'm trying to figure out is this whole part of the guide cognition to explain that has to be a substantial part of the talk, but I'm not sure how to explain why it addresses the roadmap challenge. Like,
which probably means that you need to redo your roadmap challenge.
okay.
Means to.
Redo the roadmap challenge because the slide 2 really is motivation for only one of your sections and not the entire talk.
Let me think. Okay. I mean, this is basically focused. Yeah. So what is the roadmap challenge? I think the roadmap challenge is.
You just said that, right? Improving online environment.
With that, yeah. That's true. So actually, yeah, maybe if it's just even not improve linking, but actually improving online environments.
Yeah.
Because then you could say, well, why am I doing lab research? It's because I want to understand principles about how people explain. That seem more reasonable. If you want to improve the design of online environments, then one way to do that is to conduct experiments to look at basic cognitive processes like asking why. And then one other way is actually by synthesizing existing research. And then one other way is actually by embedding experiments into these platforms. And then one other way is actually by the future work, which is formulating a framework that lets behavioral scientists do this kind of work, not just me.
So what is the transition from the lab experiment to research in your work? Is trying to answer the same question about why, how does asking people for explanation help that learning, right? So what is the transition over there? Why you suggest that moving from the lab experiment to research experiment, or to the online experiment? Like maybe you can talk about the
that more
motivation
directly.
of the lab, or I don't know.
No, that's a really good point.
I think what he's trying to do is to apply the control, like environment control setting to the real setting.
Yes.
Okay. So
That's
the different things then. Like you don't try to learn. You're not exactly only trying to learn new things, but you want to change people's behavior on the real platform.
Yeah, it's actually trying to do both at once.
Okay. The first
But yeah.
part was exactly what we just read. The 2 papers, right?
Yeah.
How to come up with inductive bias, right?
It was such a deja vu.
Yeah.
Oh, really? Oh.
Right before this, we had a
Yeah, no, I saw, but I guess I think of my work as being so different from that. But okay.
About generating inductive bias.
Oh, okay.
Really
So,
interesting.
yeah, by the way, for anybody familiar with machine learning, that section will be just so confusing.
Okay.
Because what you call misleading patterns to a machine learner would be
just fine.
Would be noisy labeled examples.
Sure.
I mean, noisy data. We do not think of it as misleading. We think of it as part of life.
Sure.
Which is kind of true.
Yeah.
Teachers try to not.
I mean, misleading implies deliberate action.
Ooh.
Yeah.
And in this case, it was misleading.
Sure.
Yeah, sometimes they use the term spurious patterns.
Yes.
So
Do you think that
no
might be a
intention.
better one? Yeah.
Yeah. So, given that you first told us that misleading patterns would be problem for creating for this substantive constraints process. The way you operationalize your hypothesis was confusing because it looked like noisy data, not misleading patterns. So for the computer scientists in the audience, that there will be a moment of confusion.
No, that's a good point. And people have also raised that in previous talks. So maybe I'll talk about instead in terms of overgeneralization. Would that make it more like patterns that are partially reliable?
Is it overfitting?
No, so it's unclear what was happening, because it seems that when people weren't asked why,
yes,
they were generalizing robustly despite the noisy inputs.
They weren't using the patterns; they were just using individual features.
That's what you think?
Yeah, that's what we're pretty sure happened, because we had people classify individual features, and if you were in the control condition, you were better at that. So after the experiment was done, we gave them individual features like what color, like someone's name, and we said, what would Anna do? And people who weren't explaining were good at predicting that. People who were explaining weren't that good. But people who were explaining were good at saying people who were outgoing donate to charities. People who were not explaining were not good at saying the general pattern.
Oh, I see. So with the Y condition, people were going for more succinct, more general hypotheses.
Exactly.
Okay. So 3 times in my notes, I wrote a question. So what is the problem?
Got it. Okay.
You need to make sure that you state what your problem is and why it's valuable. Well, for the problem that you fix.
Sure.
I also wrote several times that it was unclear what the impact of the particular piece of work is.
Sure.
And don't tell me that it was a publication here or there, because that's not impact.
Sure.
And I think you may be also misstating what the impact is in some cases. So the impact doesn't match the challenge that you set out for yourself.
Okay.
So for example, in the Khan Academy section, I think you started it off by highlighting the benefits of researcher-practitioner collaboration, or marrying
sure.
the real world. And then you tell me that 0.5% improvement was your impact.
Sure.
It wasn't the impact. The impact was that
they then adopted it.
That this research-based practice was adopted both to generate knowledge and to rapidly evolve the Khan Academy platform.
Okay.
I assume.
Yeah.
That would be the kind of the logical flow.
Sure.
And you have to very explicitly state for each section what the impact was.
Sure.
And don't rely on people figuring out for themselves because they want.
Sure.
I need to leave soon, so I just give my final comment.
Yeah.
So for my impression, it's like you does a lot of work and they're interesting, but it seems like when I was from the top, I am not sure exactly what is your mission or your what are you trying to achieve here. I would love to hear a more coherent story of it.
Sure.
And so I have just determined visually slide like this. So do you need anything from my laptop?
No. Okay. And in terms of coherence, do you guys have any ideas about how I might make these? How do I make this sort of basic lab research, which, like we just said, doesn't have impact, bridge with?
I didn't say it didn't have impact.
But it's just a publication. Like, oh, you mean the impact isn't? But it's like site participants who come in and we get them to learn a bit more. Like it's never done with people out in the wild.
I said it didn't match the mission you set out for yourself, and I said you didn't state what the impact was.
Okay. Okay. So then how does this psych lab research and then this work synthesizing and developing these rating scales and then actually experiments, I'm just trying to think what makes all of these kind of tie together if people just were to try.
You have one theme.
One theme,
that lead the story. Down the road, you may have